Hello everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will see today's daily challenge on Leetcode and we will try to solve it together. So we have this problem, find the string with LCP. We define the LCP matrix of any zero index string word of n lowercase English letters as n cross n grid. Okay, so you are given an n cross n grid and you need to find the string for that. Okay, and from the string you can build an LCP matrix in this way. It is written that LCP of ij is equals to the length of the longest common prefix between the substrings I to n minus 1 and j to n minus 1. Okay, and so if you are given two values I and j, and if you are asked that if you encounter a non-zero value in the LCP matrix, let's say 3, then you can say that from those two indices you get three number of characters which are equal. Okay, so three characters which will be exactly same. So not exactly same, but the longest common the prefix will be in them will be the same. So given an n cross n matrix LCP, you need to return the alphabetically smallest word that corresponds to that LCP, and if there is no such string, return an empty string. Now alphabetically smallest, it means that here they are asking for lexicographically smallest only. Yeah, and I hope you already know what that means. So if you try to see this example, LCP of this is nothing but this ABAB. Okay, so we will first try to construct the LCP matrix of this ABAB example, and we will try to note down few observations. Okay, so you have a grid, and let's say if we were given this string ABAB, although we need to make it, but if we were given this string, what would the LCP matrix look like? So this 0, 0 index denotes that from 0 to till the end and 0 till the end, these two prefixes are the same. So what is the longest common prefix? So let's say an element I comma j. So if there is a cell I comma j, so it means that from position I and from position j, you need to write the string from it till the end of it. Okay, so and then you need to match the common prefix. So as you can see, for I comma I, the whole string is only the common prefix. So diagonal element will always have some non-zero values. Okay, so as you for 0 comma 0, as you see that you are getting the same string twice, AB, and AB, and the prefix, the common prefix between them is nothing but 4. Okay, so and if you now try to see this element, so this element says that I is 0 and j is 1. For I being 0, you start from the 0 index ABAB, and for j being 1, you start from 1, which is BAB. So between these two strings, what is the common prefix? You see that at the first element only differs, so there is no common prefix. So you write a 0 over here. Okay, so yeah, so basically in between strings you need to find a common prefix. So in order to construct the grid quickly, I hope you do understand that we need to write some strings over here: ABAB, BAB, AB, and B. Similarly, ABAB, BAB, AB, and B. So again, what is the common prefix between this string and this string? You can see AB and AB. The common prefix is AB and AB. So you can write a 2 over here. Here, what is the common prefix between this string and this string? It's 0, right? So you can write a 0 over here. Again, BAB, if you see between BAB and BAB, the whole string is common. So how many elements are common? There are 3 elements. Okay. Again, in between these two strings, this will be 0. Between these two, this will be again 0, because it is differing at the first index. So in this manner, you can pause the video and fill this whole matrix on your own. Okay. So yeah, I am just doing it directly. So after you have done it, let's try to find some properties. Let's try to find some observations about this matrix. Okay, so this matrix will be given to us and not this string. So in order to make this matrix produce a valid string, this must have some properties. One obvious property is that the first one, if you notice, the diagonal elements are decreasing. So if the length of the string is 4, okay, so the diagonal elements will be in the manner of 4, 3, 2, 1. In general, if the length of the string is n, okay, the diagonal elements of this matrix must always be n minus 1 all the way till n 1. Okay, I hope this is very clear, and I hope why this is happening is also very clear to you. What is the second observation? For the second observation, you must see that this matrix must produce a symmetric one. Okay, so why it is a symmetric one? Because it's quite obvious that if you want to compare the string from I to j, it is same as from I to n minus 1 and j to n minus 1. If you want to compare these two strings, it is same as comparing j first and then taking I, or comparing taking I first and then comparing it with j. So it is all the same, right? So basically in I, j, j, I, you are comparing these two strings, okay, from I to n minus 1 and j to n minus 1. The same thing you are doing. So the second observation comes is that symmetric matrix. Okay, so what we will do with this whole this property symmetric matrix? Okay, so we can conclude that it is sufficient to process the upper triangular matrix and create the string. Okay, so since we have got a symmetric matrix, it is sufficient to the main our benefit for this observation is that it is we will use only the upper triangular matrix to create the string. Okay, so yeah, that is one observation and its use. So what will be the other observation? If you try to note very carefully, if you get a 2 over here, diagonally you get a 1. Okay, now what does this mean? Now if you try to visualize the upper triangular matrix of any such string, you see that if you have reached some value, I am only considering the non-diagonal elements over here. Okay, if you have reached some value, okay, let's say that value is x, it means that what does it mean? That at I and j point, that x value is from I to n minus 1 and j to n minus 1, we have that much common prefix. Okay, that much common prefix is achieved already. So you must have achieved somewhere a lesser prefix. So let's say if you have achieved the length of prefix, common prefix to be 4, you must have achieved 3 somewhere, you must have achieved 2 somewhere, you must have achieved 1 somewhere. Okay, directly you are not achieving the whole common prefix. I mean to say that if you are saying that hey, ABC, these two are equal at some point in the string, it also means that this BC and BC are equal. Okay, but and if you try to notice where they will be equal, from starting from I to ij, they are exactly equal at I plus 1, j plus 1. Okay, so if I and j is a non-zero element, then I plus 1, j plus 1 should be an element with just uh, one length smaller. Okay, so if I j is x, then I plus 1, j plus 1 must be x minus 1, I plus 2, j plus 2 must be x minus 2 all the way till 1. Okay, or if there is space, there can be all the way till 0 also. So I hope you do realize that uh, for non-diagonal elements in the upper triangular matrix, if you have, let's say, a 5 written over here, then there must be 4, 3, 2, 1 present diagonally. And if there is, let's say, anywhere 6 written over here, all the way till 1, you must be present. Okay, somewhere or the other, it is definitely there. Okay, so using this, we have our third observation is that uh, if LCP ij is not equals to 0, then LCP ij must be equal to LCP I plus 1 j plus 1 plus 1. I hope this statement is very much clear to you by now why I wrote this. So if it is a non-zero element, as I told you, lying in the upper triangular matrix, then definitely it must be derived from some smaller element, maybe that is 0. And again, if you go diagonally right downwards, you must get something. Okay, so I mean, you get a length which is just smaller than that. So yeah, I hope that is very clear. So one thing you can do, so I hope if you have understood these observation and these properties, everything, I will now request you to try this problem on your own first, and then if you still can't solve, then only continue watching the video. So yeah, I hope you did try, and let's see how to solve this. Uh, Given these observations, first thing you can do is that you are given some criteria. You will be given some mappings. Okay, what are those mappings? You see, from I and J, LCP I and J, if it is a non-zero element in LCP I and J, it means that at I and at J, the position, the string, I mean the character at position I and the character at position J must be equal. Okay, so uh, yeah, you can make them equal. So let's say you start with a string with all star present in it. Okay, so let's say and I hope you do understand that what will be the length of the string. It is nothing but the length of the size of this. This is a square matrix, so LCP dot size you can just do and store n, and that will be nothing but the length of the string. Now you can initialize this length of the string with all stars. Okay, and if you just see that, and you can keep a counter. Okay, that counter we will try to keep a character counter. Okay, it will tell me that what is the character which I must fill in the star which I am currently at. Okay, so I will iterate through this string and see if the current element is a star. Okay, I can put this uh, C value, whatever value is there in this character C, I can put at that index. So S of I, at that S of I can just put this C, and I can then increment C. This thing I can do very simply. Okay, and after all of this, I will also iterate through J. So double for loop, right? uh, for when I iterate through the I keep this C over here and increment C. And as I go from J, as I told you, you need to only iterate in the upper triangular matrix. So J equals to I+1, J less than N, J plus plus, something like this you will write. And from here, you can just put, let's say the string, whatever is this, string J equals to string I. Okay, and string I, you just put C over here. Okay, and yeah, that much you can do and build the string. Okay, just build the string in this way. Just keep building the string until all the characters are non-star. Okay, so yeah, you just build the string in this way, and after doing this, all you need to check is that uh, you is this string giving me the valid LCP matrix. So there can be a possibility, you see in this third example they've given, there can be a possibility that what is the difference between this example 2 and example 3? If you try to notice that only this element is varying, only this element is varying, and you, as I told you, the diagonal elements must be 4 3 2 1, right? So the diagonal elements here are not 4 3 2 1. It is 4, then it is 3, then it is 2, then it is again 3. Okay, so therefore the string is not possible. Okay, so the string which we just now built, it is possible or not, you need to check with these criteria or with your these observations. Okay, so if these observations somewhere it is happening that the matrix is not symmetric, or somewhere you see that this criteria is not getting true. Okay, or you see that there is a non-zero element. Okay, but still, what does non-zero element represents? LCP ij. If it is non-zero, it must mean that at position I and at position j, whatever the string, okay, at position I and position j must be, it must be true that these two elements are equal if LCP ij is non-zero. Okay, so if you see in some place that hey, it is non-zero but still they are, I mean, if it is equal but still they are zero, then you have to return an empty string. Okay, so let's see, let's try to do the coding portion now. So we have n, which will be nothing but lcp dot size. uh, we have string s. Okay, this string is nothing but n and consists of all stars. Okay, after you get this, you can have a character c which you want to increment, and initially that character c is nothing but a, and after this you can just simply build up your whole array. Okay, so for j equals to, as I told you, you only need to iterate through the top half of the matrix. Okay, and what you do here is that if I told you, if LCP ij uh, is not 0, right? Or it is greater than 0, I'm telling, then what you do, you do the string. So this is, I have made this s, so I will try to write str. So if s it is true, then you just make str j equal to str I, right? Just make them equal. But str I must also need a value, right? If it is also star, what is the use? So if you check that if str of I happens to be star, you need to replace it. Okay, you need to replace it what by what? Str of I is C. It will be replaced by this character C, and you just increment this character because you want to move to the next character now, and you start with A because you want the lexicographically smallest one. And if in case you see that C somehow exceeds Z, you can return an empty string, because yeah, that is not possible, right? Only alphabetic characters are there, and if there is any discrepancy, you need to simply return this. So after this, you might think that, hey, I will simply return string, but yeah, of course you can't do that. You need to check the criteria also, that all the criteria in this LCP matrix are being valid or not. As you saw in the last example, that this criteria is the diagonal criteria, diagonal element criteria is being violated. So we return an empty string. Okay. So now we need to write the criteria, right? The criteria for empty string, for returning empty string. Okay, so what will be those criteria? Let's try to see all the elements, iterate through all the elements, and see if they are at least given correct in the LCP matrix or not. Okay, so we have this j plus plus, and yeah, after doing this, what are those criteria? Now it happens that str of I equals to str of j, the string which we build, if it happens that these two elements are equal, then what did I tell? That LCP matrix should be non-zero at that point. Okay, must be non-zero at that point. So yeah, and if you see, this criteria we already checked over here, because that only we built. But if it is not equal, there must be 0, right? So if it is not equal, LCP ij must be 0. But in case if it is not 0, right? What if it is not 0? Return the empty string. You do realize, right? Because if the two string are not the same, then LCP ij must be 0. So in place of 0, if anything else is there, you simply return this empty string. Okay. Yeah, now you need to check for some more criteria. You can check that if LCP of ij equals to LCP of I plus 1, j plus 1 is not equal, right? If it is not equal to this j plus 1, right? Then again return an empty string. Now, I hope you do realize why I have to write this, because yeah, this is our third observation which must hold true. If it is not holding true, then also return empty string. But now you see that since you are iterating till n minus 1, this might cause an index error, right? In order to get rid of that index error, what you will do, that if I equals to n minus 1, okay, or if j equals to n minus 1, then what will be the last element? Last element should be 1, right? Else if I will say, and yeah, I can just right? This also, or else if only. Okay, so if this LCP of ij should is not equals to 1, not equals to 1, again return an empty string. Now why I am telling that at for index n it should be 1. Why? Because you see, mm, if you are having an LCP array, okay, LCP this 2D array, and 3 2 1 at this point, if I and j, this is also corresponds to I and j, right? And if it says that string at I equal to string at j, then you know that this is a non-zero character, okay, non-zero character. But since this is n minus 1, this is either I and j, since this is the last element, okay, I'm writing the base case. So since this is n minus 1, this will be 1 only, this cannot be anything else. So uh, that's what, if it is n minus 1 n minus or j is n minus 1, LCP must be 1. If it is not 1, again you return an empty string. So that is all, I guess. If you try to submit this, let's see if you get a correct answer or not. Yeah, you get accepted for these cases. Try to submit for all of them and see if it is correct. Yeah, it was correct, and we also get a decent runtime complexity. I hope the approach as well as the code is very clear to you and there is no doubt. If you have any doubt, you can definitely ask me in the comment section. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.